Hello viewers, welcome to this video lecture series on computer networks. In my previous video, I started explaining you about the IPv4 addressing. This particular concept I wanted to explain in detail, and that's the reason I thought let me take all types of examples here so that you will have the confidence to solve this kind of problems in theory exams or face the placement interviews, and also in the lab you will be able to learn how to assign the IP addresses to the different networks in the experiments. So here let me continue from the point wherever I had stopped in my previous video. I stopped at this point wherein I explained you about one example, okay, and I gave an IPv4 address which belongs to class A. Normally if a IP address is given as 10.12.16.32, okay, if it is given like this without any slash, even then you are going to check what the first byte and you will say that yes, this particular IP address belongs to class A because the first byte is 10 and 10 falls in the range of what? 0 to 127. Suppose if they give the same IP address in 16 with slash notation and writing down 8 here, then it becomes very easy. The IP address that is given in the question is having a different value other than 8, like 12, 10, something like this. That time what? No, you have to check the first byte only. You always have a habit of checking what the first byte in an IP address, irrespective of whether the slash value is 8 or more than 8. So you will be you will be able to immediately identify the type of the class. My next example is similar to this kind, but here I wanted to give you a prefix value other than 8. So let us see one such example. I have decided to give you an example so that you can compare parallelly here with the solution that which I have solved earlier. So next time what we will do is we will take the same IP address 10.12.16.32, but what the slash value will be 10. Once the slash value is 10, that means the prefix value is 10. If prefix value is 10, that means the number of bits that are used to denote the networks, that is network ID, is denoted by 10 bits here. Earlier it was 8 bits and it was class A, so it is easy for you to immediately tell the type of the class. Now also it is easy for you all to tell the type of the class because what you will do is you will just observe the first byte. So you will write here, okay, finding the type of the class is class A. So the very first, okay, solution for the first one you have written here, it is a class A IP address. This is what? This is the example 2, okay. And the first one you can take this as example 1. And my main aim here is to show the difference between what the solution in both these cases. What is the subnet mask? Next thing is you need to find out the value for the subnet mask. So though it is a class A address, but the subnet mask will change here. Because in class A, if the prefix value is 8, the default subnet mask only you are going to write here. Because what? No, the subnet mask is going to give you an indication of what? The network ID bits. Network ID bits are 8 here. So 8 bits are denoted. That is why you will be getting the decimal value as 255. So now here if you have to calculate the subnet mask will be differing here. Even though it is a class A address, you are not going to write this subnet mask. Why did you write 255? Because you can see very clearly 8 bits. 8 bits are meant for the network ID and it is a class A address, and the default mask is default subnet mask only you are going to write 255.0.0.0. But in this case you cannot write 255.0.0.0 because the number of bits that are used to represent the network ID is 10 here. If it is 10, then you just see out of 32 bits, if you are going to write 10 bits as ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, and then the remaining bits will be what? Zeros. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, okay. So this is the value in binary here for the subnet mask. If this is the case, then you just see now the equivalent decimal value, this is 255. And what about this one? The decimal value for this is how much? This is 2 to the power of 7, and this is 2 to the power of 6, and this is 2 to the power of 7. So 128 plus 64 is how much? 2, 6, 7, 8, 9, 192. You will be writing 255.192 and for this it is 0, and for this it is 0. So the subnet mask value in this case will be 255.192.0.0. So this is how you need to calculate the subnet mask, where in a case where class A address is only given but the prefix value is something different. Because even the same procedure we have followed here for class A also, that if you write this in the binary, 8 bits you just write in binary 5, 6, 7, 8, the first octet, and the remaining 24 bits will be zeros. So in this case what has happened? This is 255, this is 0, this is 0, and this is 0. That is how you got the subnet mask for this particular IP address. But here in this case you got how much? 255.19. So this way, this is what normally the students are making a mistake here. Though they see that okay, this particular IP address belongs to class A, but immediately what they do is they write the subnet mask as this one only. This is not correct. This is only the default subnet mask, wherein if the prefix value is equal to n, only then you write like this. Other than n, other than 8, if it is 10 here, but it is a class A address, fine, because you have checked the first byte. So what you will do is you will write this 10 bits, okay, once, and the remaining zeros, and you have arrived at it. So what does the subnet mask actually indicating? It is indicating that the number of network bits are now 10. Normally the number of network bits are 8 only. The number of network bits are 8. But what has happened is, see, in class A addressing, 3 octets should be zeros. That means all 24 bits should be zeros, and all 24 bits are representing the host. But if at all like this, 2 ones have come here, that means these 2 are denoting the subnet bits. Now you will be coming across one more word called as subnet. A subnet is also a network within a network. Subnetwork within a network. Subnetwork within a network is called as the subnet. So anytime if the number of bits from the host sections are borrowed for network ID, then those bits, number of bits if it is borrowed from the host part, then those bits are called as the subnet bits. And we can create subnets here using those 2 bits. Now here in this case it is 2 bits. If it is another example wherein if this is 14, then you will be having how many? 8, 9, 10, 11, 12, 13, 14. 6 bits will be representing the subnet bits. So this way you have to understand the concept of subnet bits here. That's the reason even an example of this kind is given. Instead of number of networks, they always ask number of subnet bits. If number of subnet bits are asked, then you can easily check, yes, number of subnet bits in this case is 2, and because we have 24 bits denoting the host part, out of that 24, 2 are borrowed for the network part, and those 2 are the subnet bits, so your number of subnet bits equal to 2. Fine. If an IP address is having a default subnet mask, only then the number of actual networks, but in this case it will be number of subnetworks. Number of subnets. How many subnets you can form? There are, see, always how to get the total number of subnets. Number of subnets will be always 2 to the power of this network bits. Number of subnets equal to 2 to the power of n. This n is denoting what? The subnet bits. So in this case it is 2 to the power of 2. 4 subnets are possible. So 4 subnets are possible in this network. Then they have asked you number of IP addresses. That is what the actual host, the number of IP addresses or number of host. Number of hosts equals to how much? Now you just see the host bits. Out of 24, 2 are taken and 22 are there. So 22 means 2 to the power of 22. Number of hosts will be how many? 2 to the power of 22, and it is 4,194,304. See the difference? Number of hosts is becoming 2 to the power of 22, and it is 4,194,304. Compare this with the previous one. How much you got number of hosts? Number of hosts is equal to 2 to the power of 24, because all 24 bits were the host bits there. So around 17 million, that is 16,777,216. So now you compare the number of hosts. It is reduced here. How much it is reduced? It is reduced almost to like 1/4 of what you got. The reason is very clear also. You are able to find out, you are able to form here 4 subnetworks, and each subnetwork will have these many hosts. So if you multiply 4194,304 into 4, because you are able to form 4 subnets, definitely you will get this 16777,216. So understood now why this subnetting is needed. It is very difficult to manage a larger network. We divide that network into subnetworks. So in this example, I have taken the same IP address so that I wanted to tell if at all the networks are not divided, then each network will have 16,777,216 hosts. If the network is divided into 4, if each network is divided into 4 subnetworks, then each subnetwork will have how much? 4,194,304 hosts. And also definitely, if a smaller network is there, it is easy to manage also, like the packet need not travel through the entire network, okay, facing all the routers. Instead, it will be restricted to a smaller area only. If at all I have to give an analogy, you take any institution, the entire college from the principal side is very difficult to manage. It will be divided into different departments. So separately for every department there is a head, and it is easier to manage a single department separately. So this is how also the larger network is, and it is easy for a packet also to travel. That means it need not face the unnecessary traffic in the network if it is a very huge network. So this way you got the total number of hosts also. Number of usable host is always what? The total host minus 2. So number of usable host will be 2 to the power of 22 minus 2, which is equal to 4,194,304 minus of 2, which is equal to 419 many hosts. You are subtracting 2 IP addresses here. The first one, which is denoting the network address, that means here it will be subnetwork address, and the other one will be the last one will be the subnet will be the broadcast address. Excluding these two, you will get these many usable hosts. Then you have the network address. So just see, it was very easy here to find out the network address. Where did I write here? Because we know that only in the network address the network bits will be as it is, whatever is there in the IP address. The remaining 3 octets you are writing it in terms of zeros only. The given address is 10.12.16.32. First write down the equivalent binary value for the given IP address. Now check that there are only in this particular IP address there are 10 bits that are representing the network ID. So for the network address, what is the procedure? Keep the 10 bits as it is. This is 8. Let me use a red ink pen here. So here what I'll do is 10 bits you have to write down. You have to write it as it is. That means you are not going to disturb the 10 bits. 8 are in this octet and 2 falls under this. Then the remaining is how much? Remaining is 22. 22 bits you are going to write it as zeros. So this will be 0, 0, 0, 0, 0, 0. All bits you simply write it as zeros. For what? For the network address. And these bits are as it is. As it is, that's why I am putting a arrow direction. I am writing it as it is. Okay. So this way you have to write. Once you write this, you convert this into decimal equivalent. This is 10. Here it is what? 0. The next is 0. The next is also 0. So this is your first that is the first address or the network address. Then next you have to find out what? So this one is what? The network address. Next you have to find out what? The broadcast address. And in the broadcast address, except the 10 bits, the remaining 22 bits you have to make it as ones. So you are getting 10.63.0.0/8. Okay. This is the broadcast address. Suppose if I have to just show you the range of addresses in this case, what has happened in this example is the first address or the network address is 10.0.0.8. Okay, this is the first address what you got, and sorry, it is not 8, it is 10 here. Okay, and the last address what you got is 10.63.0.0/10. So this is the first address and this is the last address you got. In between address somewhere, okay, this address was given to us to solve the problem. So this is what I wanted to tell you. Whatever address is given in the problem statement, that is actually one of the address in the complete range of addresses. So in that range of addresses, if this is one of the address, what is the first address and what is the last address? These two you are able to find out from this procedure. Fine. Now I think the concept is very clear now. First you have a network here, then you have subnetworks within each network, and then in each subnetwork you are having these many hosts, okay, these many IP addresses are possible, but these many usable hosts are there, and this is the first address and this is the last address. Hope this particular topic is much clear to you all. This is the difference between what an IP address which is given with the default prefix value and an IP address that is given with a prefix value other than the default value. This time I have taken an example of 130.16.24.8.8/16. So first thing is you need to find out to which type this particular IP address belong to which class. So which class it is, you have to check the first byte number. The given address is what? 130.16.24.8/16 can be given, or even if they don't give the slash value 130.16.24.8, even if it is given in this manner also, no problem, because you are going to check what? Only this first byte here. And moreover, this is a notation which we call it as in CIDR notation or the slash notation, and this is the notation that is used in classful addressing. So you will be first writing the answer for the first part, type it is a class B address. And what is the subnet mask they have asked? Subnet mask you can easily determine because the value here is given. If not given, you know that it is a class B address, and in class B address 16 bits are meant for the network part. So subnet mask always give you a indication of how much is the network part, or that means how many bits are for the network part and how many bits are for the host part. So in class B you know very well that 16 bits, so here I am writing in decimal, 16 bits are for the network part and 16 bits are for the decimal. So this also you have written. So this is class B. Then third one is number of. Now let me come back once again here to number of actual networks. So I will be changing whenever I am using a problem of that sort. I will write number of subnet bits, here number of networks, fine, and number of actual networks. Wherever the default value comes, it will be number of networks and number of actual networks. How to determine the number of networks? Number of networks, 16 bits are meant for this, so 2 to the power of 16. So let me write here number of networks equal to 2 to the power of 16. Always remember that you will get number of networks by writing in terms of what? Powers of 2 of 2 to the power of what this value is representing. 16 is representing the network bits in class B addressing. 16 bits are representing the network bits in class B addressing. So you will be writing 2 to the power of 16. You are getting how much? 65,536 networks. Number of actual networks, how to find out? Always whatever bits are used to represent the class, that you have to exclude, because we have already seen that in class A the first bit is always starting with 0, and 0 indicates what? The class type. 1 bit is used to represent class A, the first starting bit, and for class B it will always what? Any binary IP address, the starting IP address will start with 10. So these 2 bits are used to represent what? The class, that is the class B. They represent it is belonging to class B. So out of 8 plus 8, 16 bits, you have to subtract 2. So you will get how much? 2 to the power of 14. Actual networks will be 2 to the power of 14, because those 16 bits are meant for the network ID. In that 2 bits are representing the class only. So if you remove that 2, it will be 14. 16,384. So this is what is the actual networks. Now what about number of IP addresses or hosts? See, I am just writing both the words here. Sometimes number of total host, number of total IP addresses, all these things will be same only. So what is that you have to do? Just check the number of bits that are used to represent the host part. Host part is always 16 in class B. 16 bits are used to represent the host part in class B. Fine, always check with the subnet mask value. How many bits are meant for the network part and how many bits are meant for the host part. In this case, 16 bits were meant for the network part, 16 bits are meant for the host part. So you can calculate the total number of hosts here. So total number of hosts will be equal to total number of hosts or IP addresses. In bracket I'll write both because sometimes it will be asked as IP addresses only. 2 to the power of 16. So in each network, 2 to the power of 16 means 65,536 hosts are possible in each network. How many networks are there? 65,536. And then in each network, 65,536 IP addresses are possible. But out of that, usable hosts are how many? Usable host, you need to subtract 2 IP addresses from this. So you will be getting 2 to the power of 16 minus 2, which is equal to 65,536 minus 2 equal to 65,534. Only 2 addresses you are subtracting. The first is what? The network address and the broadcast address. These two if you subtract, you will be getting that many. Next is what? The network address. That is the first address you need to find out. Network address, always write the given IP address in binary. Given address is how much? 130.16.24.8/16. Okay, this is the given address. If I have to split it into binary, to find the network address, what is that you'll be doing? First, copy down as it is the given IP address. Then write the equivalent binary values so that it will be easy for you. Because here, what is the value given? 16. 16 actually in case of default subnet mask, it is not required also to write it in binary because exactly 16 means 2 bytes will be definitely 2 bytes will be covered here, and the remaining 2 bytes only you have to write it in terms of zeros and ones. So network address 2 bytes as it is means 130.16, and the remaining all will be what? Written as zeros to get the first address. So your value will be how much? 130.16.0.0/16. And to find out what the broadcast address, the host bits, you are going to write it in terms of ones. So when you want to write it in terms of ones, so it is easy here. Whenever default value is given, 2 bytes as it is you write down, because the remaining 2 bytes represent what? The host bytes, and that should be written in terms of ones only. So and the equivalent decimal value for all ones in the 2 bytes will be 255. So your broadcast address is this much. Hope it is clear to you all. Now the same example, if you take it with a different value of prefix here, not the 16, because 16 you can easily carry out. Now let us take something different number. So I'll take this as example 4 now. And what is the IP address? IP address, let me take 130.16.24.8/130.16.24.8/20. Now what is the difference here? I have taken 16 here, I have taken 20. But proceed it in the same manner. So instead of networks, it will be what? Number of subnet bits will be asked. So every time I am changing here for that reason only. And number of subnetworks will be asked. Number of subnets. So these two will be the difference here in the question. So that way you can come to know also, yes, there is some logic here in asking this, because whenever you are modifying the prefix value, the default is 16, but you are making it 20. That means you are borrowing some bits from the host part. Whenever bits from the host part are borrowed, those bits are representing the subnet bits. That's the reason in the question also it makes sense if they are asking you the number of subnet bits and the number of subnets possible. So here we will just see. So in this case, check the first byte, it is a class B. What about the subnet mask? Yes, here you have to be careful because you are going to write 20 bits as ones So 20 bits means now I will divide this 4, 5, 6, 7, 8. First byte, no problem. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8, 16. 17, 18, 19, 20. These 20 bits will be ones and the remaining will be what? Zeros. So when you write the equivalent value, find out the equivalent decimal value for this. What is the equivalent value in this? This is 255.255 and the decimal value is 240 and this is 0. So your default, so in this case the subnet mask value is 255.240.0. Fine. So this is where normally, as I said in my previous example also, students make a mistake. As soon as they see that okay, this is a class B address, they try to write this as the subnet mask value. But don't do that mistake, because you are going to check here the prefix value also every time, then write the equivalent decimal value to get the new subnet mask. So now this is the subnet mask. So in this case what has happened now, instead of 16, 20 bits are representing the network ID. But normally if you see here, this network bit ID will not change, it is 16 only. The remaining extra whatever has become ones is actually from the host part. So those host bits which you are writing it as ones become the subnet bits. So in this case number of subnet bits are 4 bits only, but number of subnets how will you get? 2 to the power of 4, and 2 to the power of 4 is 16. 16 subnets are possible. In this case number of host bits are how much? 12, no? 2 to the power of 12. 2 to the power of 12 is 4096. Fine, 4096. And how many subnets you have created? 16. Hope when you multiply this 4096 by 16, you should be getting 65,536. So very simple. Once again it makes sense here. This completely 65,536 hosts are across different subnetworks, and each subnetwork is having how much? 4096 hosts, and each and there are how many subnetworks? There are 16 subnetworks. So next is number of usable hosts. Usable host is always 2 to the power of 2 minus of 12, which is equal to what? 4096 minus 2, 4094, because in each subnetwork you are subtracting 2 addresses, the network address and the broadcast address. Next comes the network address. So here, as I said, write this in the form of binary. So what I have done is just, this is 130, fine, this is 16, 24 and this is 8. Whatever is the given IP address, I have written it into binary. Now to determine the network address or the first address, I have to keep as it is the 20 bits. 20 bits means 8 is here, 8 is here, 16, 17, 18, 19, 20, 4 bits from here. So this 4 bits from here to here, let me separate out. See, from here to here I have to keep it separate as it is. And what I have to do for the remaining bits, if you are keeping 20 as it is, the remaining will be here 8 and then 4, 12 bits. 12 bits you are going to write it all zeros. When you write all zeros, then you copy down as it is this 4 bits. Okay, and then check what is the decimal value here. Anyway, this one will be as it is only, no, because 16 plus 4, 20, so we'll write down as it is only, and it is equal to 1000. Let me write once again what is this. Okay, hope you are getting this. What I have done is, this 4 bits up till here I have kept it as it is, and the remaining all host bits I have written it as 0. Then check the decimal value, it is 130, 16 dot, now how much is this? 0001, 000, the equivalent value is 32, and here the decimal value is, what is the prefix value? /20. So this way you got it. For broadcast address, what you will do, you will write it as it is, but these bits will become 1. Okay, up till here you are going to write it as it is. Let me underline also. Here also I will underline. Up till here you are going to write it as it is, and the remaining 12 bits will be what? Ones, to get the broadcast address. Now find out the decimal value. 130 dot 16 dot, and what is this number? 0001 1111. So here let me check first. This is 16, but this is also 16, no? Yes, sorry, here there is some correction. Look here, the third byte is 16 only. 2 to the power of 0, 1, 2, 3, 4. 2 to the power of 4, 16. So here you will get 16. Whereas in this case, 1 plus 2, 3. 3 plus 4, 7. 7 plus 8, 15. 15 plus 6, 15 plus 16, 31. So the third byte is 31 and next is 255/20. So this is what is the first address and the last address. So you can always relate like this. The first address, in this example I am just telling you 130.16.16.0 was your first address, and somewhere here was the last address 130.16.31.255, and in between address was given to you people to calculate this. Okay, this is what is the range of IP addresses for that particular problem. So hope now it is very clear to you all how to find out these different components. Now we have covered class A, class B. So let us see now another example, that is the class C example. So let me take now this example, class C example I am taking here. What I have done is the same type of question I will retain, but now if at all I am giving a default prefix value, like in class C it is 24, then this will be what? Normally this will not be number of subnet bits, it will be number of networks and number of actual networks. Now in the question they will ask number of networks and number of actual networks. Suppose in case even for this question if they ask number of subnet bits, number of subnetworks, then it will be 0, 0 only, the answer for both. Now let us start this, check the first byte number. Given IP address is 192.168.86.42/24. Even without slash or with slash value, you can only you can find out easily. You just check the first byte number 192. 192 falls what? In the range of class C, so it is a class C address. First answer is over. Next one is the subnet mask, and the default subnet mask for class C is how much? 255.255.255.0, because 24 bits are representing what? The network part, and 8 bits are representing the host part. That's the reason you are writing the default subnet mask. So this is always what? In this case it is default value only. Next, number of networks. Total number of networks will be how much? Look here, how many? 24 bits are meant for the network part and 8 bits. So 2 to the power of 24 is very huge. That many networks are there in class C IPv4 addressing, and 2 to the power of 24 is, so you can see here total number of networks is around 17 million in this case. And number of actual networks, how are you going to find out? Because in class C addressing, if you write it into binary, the very first IP address, the first 3 bits are 110, and these 3 bits are always representing the class C. So this already I have been telling. For class A, the first byte is excluded. For class B, 102 byte, for class A, 1 bit is excluded, 0, and class B, 2 bits are excluded for class B, and for class C, 3 bits are excluded from the network part. So in this case, if 2 to the power of 24, you have to not take 24, rather than you have to take 2 to the power of 21. 3 bits you are removing here because those 3 bits represents the class. So we are saying that those 3 bits are representing what? The class C. And now it is 2 to the power of 21, and 2 to the power of 21 is 2 to the power of 21, 2,097,152 networks are possible. Look at the number of hosts here, because host only 8 bits are so 2 to the power of 8, 256 IP addresses or hosts are possible, but usable host will be always -2, so it will be how much? 2 to the power of 8 minus 2, 254 hosts are possible in each network. So class C addressing is what? Number of networks are more, and in each network number of hosts are less, whereas in class A it is completely reverse. Number of networks are less, and in each network number of hosts are more. Next comes the network address. Network address, I will not write it into binary exactly. You can see that only the last byte is going to change here, because 24 bits will be as it is in this case, and 24 bits cover all the 3 bytes 192.168.86. So 24 bits you are writing as it is, and the last byte that is 8 bits, you have to make it all zeros for network address. If you make it all zeros, all 8 bits zeros, and then write the equivalent decimal value, it is 0. And the slash you have to put here. This is the network address. For the broadcast address, write all the 24 bits as it is. So the equivalent value as it is only, whatever is given. Then next, the last 8 bits should be all ones, and the equivalent decimal value is 255. So this way you got the value here. So now the same example, normally in all this, in this session what I have done is, intentionally I have taken the same byte numbers also to make you clearly see the difference between the answers, so that you will come to know that if the prefix value is changed, what changes are you going to see here in the number of networks and the number of hosts. So now the next same class C address I am taking, but I am changing the default value. Here it is 24, but here I am keeping it as 30. So and check the first byte, it is class C. Fine. Next, subnet mask. Now you have to be careful, because this default subnet mask you cannot write. 30 bits you have to write it as it is. Sorry, 30 bits you write it as ones. 8, 16, 17, 18, 19, 20, 20, 20. Okay, 24, 25, 26, 27, 28, 29, 30, and the last 0. So the equivalent decimal value will be 255.255.255. And what will be this value? 255 minus of 3. 252 you will get, no? This is the subnet mask value, 255.255.255.252. Next is number of subnet bits. Now number of subnet bits, how will you find out? In class C, actually 8 bits are representing the host part. But in that host, out of 8 bits, 6 bits are borrowed for the subnetting. And if you borrow the 6 bits, then you can easily write here number of subnet bits are 6. And number of subnets are how much? Number of subnets will be 2 to the power of 6. 2 to the power of 6 is 64 subnets are possible. And number of hosts are how much? Actually in this case only 2 bits are representing the host. So what you will do is you will just write down 2 to the power of 2, that is 4 IP addresses or 4 hosts are possible. And what about usable host? In usable host, 2 to the power of 2 minus 2, that is 4 minus 2, only 2 hosts are possible in this case. Fine. Then comes the network address. For network address, write it in binary, all the 30 bits, okay, and then convert it into, so 30 means what I can do is, I'll keep as it is. Anyway 24 is not going to get disturbed, no, 192.168.86. Only 42, the last byte number 42, I'll write it in binary. So now what exactly you are going to do is, you need to find out the network address, and you know the prefix length is 30, so 30 bits you have to keep it as it is. That's the reason I'm not converting this 3 bytes into binary, because 24 bits means as it is you need to keep, no, that's why the reason I'm keeping it as it is. The last byte 42 I'm writing it in binary, it is 00101010. And to find out the network address, what is that you will be doing? Only the last 2 bits will be what? 00. So you will be writing 00, but the remaining 2 bits will be as it is, 192.168.86.001010. So write down the equivalent value, 192.168.86. What is the binary value for this? 2 to the power of 0, 1, 2, 3, 8. 8 here 16, 32 plus 8, 40. You will be getting 40 here. And slash 30 you have to write. This is the first address. And for the broadcast address, the last 2 bits you have to write it in terms of ones. Fine. These bits will be as it is, whereas so the equivalent decimal value will be 192.168.86. When you write this in terms of, when you write these 2 bits as ones, the value will be how much? The value for the binary numbers here for the last byte will be 43. So you will be getting here 43 slash 30. In this example, if I have to write the range of addresses, the first address is 192.168.86.40. Okay, this is the first address. And the last address what I got in this range is 192.168.86.43. Now look here, 40 and 43. How many? 40, 41, 42, 43. 4 addresses are possible. That's the reason, and that's why you can check here the number of possible IP addresses are 4 only. Now out of that 4, 2 will be subtracted for what? You cannot give this IP address, the network address, to any host and the broadcast address to any host. So when you subtract, you will get only 2 remaining addresses in this manner. So you can write here 192. For this subnetwork is very small. I can write down all the IP addresses also, only 42. So this is what is your range of addresses. I think this was the smallest subnetwork which we have come across, and I have written all the 4 IP addresses that are possible here in this subnetwork. In each subnet, 4 hosts are possible, and we have found out here for one subnet these are the 4 possible addresses. Similarly, in the previous examples also, out of the possible subnets, for one subnet we have determined the number of IP addresses, number of usable hosts. So hope now the things are very much clear, because this is what I wanted to plan a session in this manner. Like I wanted to cover all possible types of examples so that you'll be able to solve this confidently. That's the reason first I gave an IP address of class A with default subnet mask /8. Then next I gave immediately one more example with /10. Now both these 2 IP addresses were of class A only. Next time I gave one IP address belonging to class B with /16, that is the default value. Then I gave /20. So I gave a value /20 next time. And third set of examples, first I gave a class C address with the default value 24/24, and next I gave a example for 30. You can see here these 6 examples I have covered in this session. So this completes the session on IPv4 addressing. So I have covered the complete knowledge on IPv4. That's what is the heading for my video, complete knowledge on IPv4 addressing. I have made it into 2 videos. The first video, definitely it is required because you need to know the concepts, and in the second video I have covered the examples by taking from class A, class B, class C with the different subnet masks. I have taken class A, class B, class C IP addresses with different values of prefix. So hope this session is useful to you all. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.